Oi, hello, welcome to another KIELive. Today we have a real specialist on financial sector. She's been acting with architecture, enterprise architecture, and solution for applications that run in the financial sector. And now she's going to share a little bit on how business automation can help with anti-money laundering or transaction monitoring, just to improve a little bit the security and of your organization. Sadhana Nandakumar, who's here with me today, is working at Red Hat for more than 3 years now, and she is a specialist, a specialist solution architect. Correct, Sadhana?
Yep, that's right. Thanks, Karina.
Known as one of our tigers. So she is one of the best. So Sadhana, thank you for being here with us today. Could you just let us know a little bit of what you expect from your talk?
Sure. First of all, it's great to be here, Karina. Thanks a lot for having me. So today's talk is going to be focused on a demo that I put together recently to kind of encompass cloud native business automation, the recent updates that we've had in that space, and combine that with enterprise integration, which also Red Hat provides. So essentially providing a holistic solution using our application development suite in an open source manner. And we're trying to solve a business problem here, which is around transaction monitoring, as you rightly called out. And so the intent here is to essentially build an event driven architecture, weave in the cloud native business automation concepts, and create that holistic solution which is built for scale. So that's basically what we're going to be looking at today.
Oh, that is interesting. So, what I can expect is to see the whole architecture implemented in a demo. Not only the business automation piece, but everything with event-driven architecture and on the cloud all together. Okay, I'm looking forward to that, Sadhana.
That is accurate. Yep, let's get started.
Perfect. So, guys and girls who are watching us, as usual, feel free to drop your questions on the chat. I'll be here in the backstage while Sadhana is presenting. And Sadhana, I will now share your screen when you're ready.
Yep.
And can I share it right now?
Yes, please.
Okay. And okay. So the stage is yours. I'll be on the backstage.
Thanks, Karina. So, as I mentioned, this is essentially a solution that pulls in the business automation capabilities, the cloud native aspects of it, and combines that with the application development, capabilities that are also available from the open source. And that basically creates that holistic solution. But the intent here is to basically have this system built around transaction monitoring. So when you have incoming transactions, we want to be able to kind of take action on them in real time. As we're talking about anti-money laundering and fraud, these are financial crimes. And that basically translates into money loss. And so essentially what we're trying to do with this event-driven architecture is an ability to identify and fix an issue even before it becomes a problem. And so as we have been reiterating, we will try to combine the event driven architectural aspects along with the automation and intelligent aspects. So we're going to be tying in decisioning as a way to kind of identify touch points to see when a transaction will need to be investigated further. Similarly, we are also trying to weave in artificial intelligence and machine learning to kind of enhance or augment that decision making to make sure that the transactions are identified more accurately. In addition to this, we are also kind of tying in the ability to provide faster access to data, because essentially when we're talking about an architecture like this, we are dealing with customer context. So that's the 360-degree view of the customer. And so we're dealing with data that's spread across the enterprise. Having a way to kind of pull that data and make it available for faster access is a critical requirement when building a solution like this. And so we're going to talk about some aspects about caching as well as a part of the solution. So that's basically the architecture, the open systems architecture at a glance. So you can see that as I've been talking about, there is data that's spread across different data sources. your transaction data can be performed from an omni channel by the customer. And as this transaction data comes in, we want to be able to take action on it by performing something called as transaction monitoring or scoring. So we look at the transactions, we label them to identify if there are characteristics that kind of qualify them as being a fraud or an AML candidate. And then we push them to the corresponding teams for them to kind of take a look at. So essentially, the transaction or the event bus that sits in between, that is basically giving you that event driven framework, that real time framework that we're talking about, that supports it to kind of build this end to end architecture. And so, especially when we're talking about process automation highlights, we're going to talk about these three important kind of. I've tried to weave in these three important features in the implementation and the demo as well. So we are definitely looking at using Cogito engine for decisions. That's because it's cloud native. For one, the solution that we're trying to build is essentially meant to scale. So we want to kind of create a solution that's microservices based, and it can seamlessly communicate with an event driven system, and thereby we want to kind of create a solution that's lightweight and scalable. And so Cogito is a great candidate for that. So that's going to be one of the considerations that we will see. Event driven decisions. So we're going to make use of the event driven decisioning capability. Since we're talking about an event driven architecture, it is very evident that no two components can directly communicate with each other. It's going to be via the event stream. And so, since we have the native support on the Cogito engine to kind of talk to the event stream, we are making use of that capability as a part of this demo. And then we are also kind of considering the seamless Kafka integration for Process Automation Manager. So how do I make sure that my workflow can be kicked off based on an event that's available in a topic? So we're talking about, the ability to push the AML or the fraud cases to the corresponding teams for processing in an event-driven manner. And so that's basically one other consideration that we're going to pull in. In addition to this, we're also kind of trying to make this more of a solution, not just focus on the process automation aspects of it. And so we will be looking at cloud native integration, which will support the solution, giving it all the required data that it needs for the lookup. It's going to make sure that it transforms the data, sends it downstream, and we're also going to, factor in the caching aspect of it, which I pointed out earlier, to make sure that we have faster access to that data. And so the technical architecture looks like that. Like I mentioned, event-driven architecture. So every communication happens via the event stream, where traditionally we have seen implementations of such solution being built as a single monolithic BPM architecture, whereby you have like one workflow or one workflow project or a deployment that basically has workflows that is going to take care of the AML aspect of it as well as the fraud aspect of it. And we basically then start sending out API calls to the process engine for the purpose of execution. What we're trying to build here is essentially that microservices based, domain driven BPM, I would call it, essentially pushing out the AML concerns and the fraud concerns into their own respective services, and then basically have the ability to kind of still pull metrics from the whole system end to end. So that's basically the intent. And so you're going to have the customer performing transaction, and the transaction data is going to come into the event stream. Once the data is available, we're going to first enrich the data, because that's an important consideration. When we're looking at transactions, an individual transaction might not look fraudulent, but when you try to combine that transaction with the other transactions that happened before that, or when you try to combine that with a customer context, then it might signal an fraud behavior or an anti-money laundering behavior. And hence, what we're trying to do is essentially load up the data with respect to the customer context as well as the historical transaction context. And then we kind of push that enriched data back into the stream. This information is then being used for the decisions, the transaction labeling aspect of it that I spoke about. So that basically is going to look at the incoming event, evaluate it against a set of decisions. The decisions are both static as well as ML based. So it's basically going to be business user decisions that's augmented by anti-money, AI/ML type intelligence. And that basically goes into the stream again. We are kind of intercepting that to report on the decisioning component to give explainability with respect to what type of decisions were made. In addition to that, once that event is available after the decisioning is completed, we then route it to a corresponding topic so that the downstream teams can start working on it. So we have respective workflows defined for anti-money laundering and fraud related activities. And when an event happens to be available in the fraud or the AML topic, the corresponding workflow is spun off so that the processing can take place. And the overall metrics from the workflow engine is also kind of pushed out into a Kafka topic. So we can kind of get that event source, the single source of truth to report on, to also kind of make sure that your AML models are constantly improved. So that can be your data lake, because we are pulling data from different points in time, and the event source or the event stream has all the data end to end with respect to processing that happened for every customer. And so, yes,
Sorry,
Karina.
just sorry to interrupt you. Just before you move on, we have a question here from Naga. So, could this be integrated with any core banking solution, meaning like availability of open APIs?
Absolutely. So the nice thing about an event-driven architecture like this is it's pretty decoupled in nature. So it's very easy to kind of plug and play with, other existing services or legacy applications that you might have in-house. Now, there are several different ways we can do that. But the nice thing about the architecture is the plug and play capability. None of this is basically kind of written in stone. Everything is customizable. You can basically switch out the components which you really want to use and replace that with the other components that you might have in house. And that's why initially when I called it out as a solution, where we've seen that a lot of out of box vendors sell AML solutions where everything is essentially a black box. So you're stuck with what they give you, you're stuck with the ML models that they give you. Changing the decision points is a pain. But here, everything is customizable and it's completely in your control.
And even if some pieces of the architecture, if the person wants to change some pieces of the architecture, that's also fine, right? So because you're going to open that
Absolutely.
box. Awesome.
Exactly. And like I mentioned, this is an implementation of the reference architecture that shows one way of how this can be solved. But this is not the only way it can be solved. And what we've seen a lot of times is when we have an architecture like this, we see customers kind of tweaking this in multiple different ways, taking inspiration from the architecture and changing it to the way that will best fit their needs.
Yeah, it makes sense. So in this scenario, in this demo, are you doing any temporal reasoning on the fraud events?
So the temporal reasoning is not done in the decisioning layer. Great question. And that's one thing that will be a future addition to the demo. For now, the historical context is loaded from a database via a cache. And we are also kind of using that historical data for our ML models so that your ML model basically predicts based on the customer context and the past historical transaction data. But reasoning over the stream is something that I would like to add to this demo in the future. And again, that would mean that the customer context lookup, the microservice that kind of precedes your Cogito decision service, will need to read data from a couple streams, go back in time, do that historical lookup, and then enrich that data.
Okay, perfect. Okay, you can move on. Thank
Perfect. All right. Thank you. And so with that, let's jump right into the demo. We'll come back and look at what pieces kind of come together to form this architecture end to end. So let's get started. What I have in here is a simple e-shopping application. So the intent is that I'm going to make some purchases in here, and we are going to kind of look at what happens behind the scenes. And in order to kind of help us understand what's going on, I have like the back office view of the transactional context here. So we can understand as transactions happen, what happens behind the scenes. So let's go ahead and perform a very simple transaction here, a $56 merchandise. Nothing too fancy about this transaction. I'm going to choose the card ending in 4567, and I'm going to go ahead and do the purchase. Now, as soon as that transaction kind of went in, the transaction ends up, coming into the event stream. You can see that the transaction was evaluated against the decision model, and it happened to, be a clean transaction. So no investigation was required. When you look at the transactional characteristics, there was nothing that kind of stopped it from, being identified as AML or fraud, which is essentially why we kind of sent that through. But let's go back and perform another transaction. This time around, I'm just going to switch the country of purchase. So I'm going to choose, Congo as the country of purchase, and still do the same $56 merchandise. So it's the same kind of product that I bought, but from a different country. And I'm going to choose the same card, and I'm going to go ahead and perform that transaction. Now, when that happens, the transaction is being looked at for characteristics, and one of the characteristics that we have configured as a part of the rule is the country of origin. So if the transaction was performed in a country that's not in the allowed list, it's basically going to flag that as fraud and have somebody take a look at it. And so in this case, we can see that the transaction was blocked, and it was blocked because it was a blocked country, right? Now, what happened behind the scenes, right? So I have a transaction that came in. We are able to inspect the event stream, and we understand that the transaction was indeed marked as, fraud. But why did that happen? So in order to understand that, let us look at the cogito decision that kind of powers this. So what I have in here is essentially that cogito DMN model. So as we all understand, the decision model notation is essentially giving that easy way for business users to kind of order the rules, the drag drop capabilities and the field expressions. And so here we are basically trying to understand if there is fraud related characteristics or AML related characteristics. And if you remember, I mentioned we have the risk index that we are calculating from an ML model. Again, I'm trying to factor in this as a part of my rule. The ML in our example is being deployed using the Open Data Hub. So it's basically exposed as a prediction service, where we have like a model server, and we are essentially enriching that information, getting that prediction data even before we come into the decision layer. So I'm using more of that decoupled approach, whereby you have the machine learning engineers creating these machine learning models. They deploy that to the model server, and then you interact with the model server by using APIs, fetch that information, and then pass that down to the decision layer. So combination of that, when you look at it, there is the fraud definition. So as you can see, I've basically kind of created a composable model. So we have a DMN definition for fraud. We have a DMN definition for anti-money laundering. And let's look at the fraud related DMN model here, because that's exactly what we did right now. So we consider simple things like merchant type, transaction amount, the type, and the country of transaction. And we come out with a determination if it's going to be blocked. And if it was blocked, it's basically going to tell you why it was blocked. So that's basically the DMN model in there. And let's say in this particular case, the transaction was a simple $56 transaction. We saw that. And that was the merchant ID that came from. And we basically performed this transaction from the Democratic Republic of Congo. So that's basically where we perform this transaction from. I'm just gonna put that in there. Okay. And so that basically, you can see that the transaction was essentially blocked for that reason. So again, the cogito decision has been deployed in an event-driven fashion. So it's basically reading the input from a topic, evaluating the decision, and pushing the response to a topic, which is kind of what is interpreted downstream by the other components, and which is why we saw that the transaction was blocked. Okay, so now that the transaction is blocked, we understand there is a fraud characteristic associated with this transaction. What do we want to do next, right? What's the downstream action for this? Let's look at that in action here. So essentially, what happened was I've set up a workflow that basically can respond to an event that is available in the fraud topic. And in this case, as soon as the transaction was available in the fraud topic, the transaction workflow was kicked off. You can see that it basically gives you a complete context of what happened with that particular request, and it's currently being worked on by the fraud agent. So again, if you go back to what I mentioned in the beginning, although the AML teams and the fraud teams will have different workflows, will have individual responsibilities and different kind of requirements for processing the cases, what we're trying to do is tie them together using the transaction monitoring system. So you have that single pane view of the processing that's happening across the AML space and the fraud space. And we are able to get that overall reporting from across the end-to-end system. So let's go back in here and let's try to look at what an AML activity might look like. A fraud is a fairly easy concept because we understand that a transaction has to have a separate characteristic, and if it does not have that characteristic, then we basically block it. Now, let's say we want to identify AML characteristics. Now, like AML characteristics is slightly different in the sense that a transaction might look legitimate all by itself. It's probably not going to fall in any of the fraud related attributes. It's going to be a clean transaction as you look at it, even with respect to the earlier transaction history. But when you try to combine that with other things in there, so things like, is this person politically exposed? Is this an out of normal behavior without having any kind of life changing event for that person? So let's say I don't normally purchase any luxury purchase items, right? I don't do any luxury purchases, and I'm suddenly making a large luxury purchase, and I'm paying that using cash. And I don't have any life changing event associated with me. So I didn't move jobs, I didn't move to a new city, I didn't get married recently, whatever, right? So all of this could kind of in a combination signal a possible anti-money laundering activity. And so that can essentially be pushed to the AML queue so that somebody can take a closer look at it. Somebody can do a more of a long term monitoring to understand if there is one or more activities like this that is happening with that customer going forward as well. So in order to kind of catch that behavior, I have a simple example here. So that's like a Birkin handbag. It's a transaction amount that is, not very large. It's $9,500. It's not as large as a fraud. So it's basically saying, I have certain transactions which I want to be blocked as fraud if they are over, let's say, $25,000. But this is not that big of an amount. But this transaction has some other characteristics which could signal an AML behavior. So in this case, I'm just going to go ahead and do this transaction using a cash purchase. So like I mentioned, the history says I haven't done any kind of large purchases, large luxury purchases like this in my normal. And so I'm going to do this purchase and I'm going to do this using cash. So let's go ahead and create a transaction. Now, as soon as the transaction kind of was created, there's going to be behind the scenes the there's going to be an AML rule that's going to kick in to kind of identify if there is any characteristics that were identified so that it could be blocked, right? So now let's go back into the rule that kind of defined the AML behavior. You can see that there is transaction amount, the average transaction amount. I mentioned that when a transaction amount is over a specific amount, and that's not my normal behavior, and I want to combine that with a life-changing event. So we are looking at characteristics like, is this person married recently, an employment update, or a city change? Any of these characteristics could signal an AML behavior. So that basically then combines to identify if there is an AML alert that needs to be raised. Now, this is not a confirmation that AML could have happened, but we are trying to push this to somebody's queue so that they can take a closer look at it to understand if there is future kind of monitoring that needs to happen in this space. Now, if you look at it in this particular case, it was not a really large transaction. It was a $9,500 transaction, but this person did not have any life-changing event. So no kind of anything that is associated with a life-changing event, and the transaction was done using cash. So you can see that that was basically the out of normal purchase. That's basically kind of stopping that transaction to identify to basically say, this particular transaction will need to be taken a closer look at. Now, once that is done, we could then kind of try to factor in other information like, is this person politically exposed, or this person is, linked to some sort of an advertisement agency. And there are several other categories that we can try to kind of factor in there to determine if there needs to be a closer look, or if they needs to have a closer tabs on this person as they perform this transaction. Now, I wanted to kind of also kind of talk about the AML aspect of it. I mentioned that I have used an AML model in this particular use case, which is essentially predicting fraud in financial services. It's basically looking at characteristics like the transaction amount, the average transaction amount. It also tries to kind of consider or factor in what is the account balance for this particular customer in the last 30 days, the last 60 days. It tries to combine all of that information, and it exposes an API. Now, this API can then be accessed to kind of get the evaluation to identify if a transaction that comes in is potentially fraud. So it is trained using a specific data set. And if you remember, I mentioned the event source is basically the source of truth. So that can basically be fed back into the loop, and the loop can continuously keep enhancing that data to make sure the model is trained in a continuous fashion. And in this case, I'm actually deploying this. So I have an S3 endpoint that I've set up, and I've actually deployed this on a model server so that we can consume that a model and use it for the purpose of our evaluation. And one other kind of related concern here is, okay, I have the transaction data. There's going to be data that I will have to kind of hydrate with respect to historical perspective, with respect to the predictive perspective, like I just showed here. How do I make sure that I have faster access to data, right? We're talking about real-time responses, transaction coming in, evaluation is done almost instantly before we kind of respond. How do I make sure all of that happens? And so for that, what we have in here is the data grid cache, which I've set up. Again, it's an in-memory cache. Basically provides faster access to data. So any underlying data that you already have, we kind of create the single pane view or the 360-degree view of the customer. We create that data, and that is basically kind of loaded up into the cache. And the cache can then basically use that information, serve requests as we are receiving every single event that comes in. Again, with respect to the data engineering aspect of it, we are not essentially talking about how we are pulling in the data. We're talking about how we are providing faster access to the data. In my example, I'm pulling in the data using integration components. So I'm using, Fuse as a way to kind of pull in data from across the different sources. But to an earlier question, that can easily be switched out with other tools that provide that virtualization over data, and that can basically be served via the cache to provide for faster access. So we looked at, the end-to-end. I showed you that there are several pieces that are kind of tying in the architecture. Let's look at each of those individual pieces. So you have the customer performing a transaction. It came into the transaction stream. We then enriched the data using Open Data Hub and Data Grid. That data was again put back into the event stream. We then evaluated it using the Cogito decision. Again, we are using the event-driven characteristics here, as I called out. We are then kind of pushing that out into the respective topics so that you can have a workflow that basically takes a look at it and starts processing them. So that's basically all of the products that come in together. And an important consideration is that piece, which is reporting. So when you're talking about an event-driven system and a system of this nature, real-time transactional data, we're taking decisions on the data, it's going to be super important to have that traceability to understand why a specific decision was made, go back in time and understand if our decision models are performing well. It's not just important for the privacy related kind of reasons, but it's also important for regulatory reasons. We want to make sure that there is a path to trace back and identify why a specific decision was made. So what I'm doing in here is setting up reporting. It's going to read both from the decision response as well as from the process automation manager's audit response. So we're basically pushing in every committed metric to the Elastic cluster, and we're visualizing that to provide that business activity monitoring for the overall end-to-end system. So let's look at that here. So what I have in here is the Elastic dashboard. So you can see that we have the total number of events that came in, the events that were identified as AML or fraud. We are able to look at that's the timeline that is being pulled from the audit log for processes and tasks. So we can see, based on the time, how many processes were created for the fraud workflow and for the AML workflow. Similarly, you can look at how many of the tasks were created for each of those workflows. We have categorization based on country, what type of transaction they were, whether they were valid or AML alert was raised. So you basically have different characteristics. And again, that information is coming right from the data that's being sourced, both from the decision point as well as from the business automation point. So as in the committed process metrics and the task metrics are also being pushed. So all of that is basically kind of powering this Elastic dashboard. And if you go back into the view that shows how this event-driven system works, we spoke about, you start with a topic, and then that topic basically enriches the data. Then there's a consumer that takes that and evaluates the decision. We then kind of route it to different places where the workflow can begin. So there's at least 5 or 6 topics involved in here. So you can see that we start off with the event input stream topic. So that's where all your input transactions come in. So if you inspect this particular topic in here, you can see that there are several of those transactions, and that's the event type that comes in. So let's, for example, look at the last transaction that we had in here, which was the merchandise for $9,500, which we kind of called out earlier. And it was from the Democratic Republic of Congo, and it was like a merchandise purchase, right? Now, if you go back into the next event, so that we basically enrich that topic, right? We take that data, we enrich it, and we provide it for the decisioning by our DMN model that I showed earlier. And so the decision request is essentially pulled into a Kafka topic. This is where your Cogito decision is reading it from. So if you remember, the Cogito decision, the event-driven decisions basically work with the cloud events type format. So that's basically the format that we're sending the data in. So we have the transactional context going in along with the enriched data. So you can see that we are enriching that data with the average transaction amount, all of the personal information about the customer, along with the type of payment. So we're also considering things like whether it was a cash payment or whether it was a credit card payment. So all of that information is sent in. And then we basically go into the response of this. So that's basically where your Cogito decisions evaluate the response. So we saw how the event-driven decisioning concept reads from a Kafka topic, a cloud event from a Kafka topic, and writes to a Kafka topic, which is again in the cloud events format. So you have the response topic in here. So when you look at that, you can basically understand what happened in here. The response was identified as an out of normal transaction for cash purchase. So that basically was the evaluation that came out of your Cogito decisions. And again, when you switch back, we then kind of push that to corresponding AML or fraud related topics. So if you look at the AML topics, the last transaction was an AML transaction, if you remember. And you can see that this particular transaction was identified and it was sent over for processing. So your business process is basically going to react to that event that is available in that topic, and it's going to perform the workflow based on receiving that event. And last but not the least, I wanted to call out that we also have a couple of reporting related topics. So remember, if you mentioned, I kind of pull both the decision metrics as well as the audit metrics from our process engine. And so we have the topics for the JBPM process event and the task event. We are also kind of having that reporting topic, which is where I push the DMN evaluation responses onto a topic so that it can be interpreted there. So that's basically how your event driven system is tied. It's basically tying in all of these different pieces together to make that holistic solution. And if you kind of go back and look at the deployment itself, and again, we spoke about how this is all in the cloud. That's how all of this is deployed. Um,
Before that,
yeah, yeah, yeah.
because you mentioned reporting and you've shown a lot of data that is gathered, but is this demo, it doesn't cover the next best action, right? Would that be possible to be implemented?
So the next best action in this case is the workflow processing. For example, in our fraud case, we saw that the next best workflow was basically to identify, the fraud investigation has to be done. There could be transactions which could be blocked for both, both the categories. Then you're going to have like two different workflows being spun off, and that's the best action. In this case, if a fraud is identified, we basically block that transaction and send out a customer notification right there. This is to make sure that even though if it's a legitimate transaction, we want to get the customer consent before making the transaction, or before approving the transaction essentially. And so that's the next best action piece of it. The nicer thing about the event driven system is that you can plug and play multiple downstream systems. So in my case, it was a workflow which was doing the downstream next best action. This can totally be switched out with some custom code. It can be switched out with human behavior. It can be switched out with, just analytical views and such. So it's completely up to the use case where it's being implemented and the customer requirements. But yeah, that's how we kind of tie in the next best action or the response downstream.
Perfect. Everybody is loving this demo. So another question.
Mhm.
So great demo, by the way. How would a multi-event temporal decisioning scenario be supported in this architecture?
Yeah, great question. So, like I mentioned earlier, the multiple temporal event use case will be handled using the customer context lookup scenario. Now, the customer, as we all understand, the data is going to be spread across different data sources. It can be in databases, it can be in legacy systems. With the event driven system, event sourcing is a very famous concept. So, if you can pull data from these sources, populate them into topics, the Camel microservice can actually read from one or more topics, collate that data, and do the interpretation. And in the past, we have done interpretations by using, in-memory queues, whereby we have the HA being established in the sense that you actually read from a topic and you read from the same topic has historical context from the beginning all the time. So there is rehydration possible whenever the microservice dies and comes back up. So you have the transactional data, which is the current data and context, and you're going to have a way to kind of keep track of what event you're processing. But there's going to be another topic where you have the historical context. We always read from the beginning. The interesting aspect to engineer that piece will be partitioning the data. How do I make sure that the data is partitioned in the right way? So when I'm looking for the customer context for a particular customer, I'm able to look that up. And it's a concern with respect to implementation. But that's a concept that we've implemented in the past, and it's very much doable. Again, like I mentioned, that's going to be a future addition to this demo to kind of pull in that ability. And that's using Fuse. We could do the same thing using something like K-streams, because you have the ability to perform aggregations on the stream right there using the K-streams API. So that can also be used to kind of do that temporal check, load up the temporal data into the decisioning layer, and perform the aggregation using the DMN's library functions.
Wow. Everybody's just woo awesome. I told you guys she was one of the best. Not so okay. There's just one more question, but I will save this one to the for the end, and I will take it myself. That is why you are talking about cogito decisioning and not rules.
Mhm.
So hold your thought, guy. I will talk about this in the end. So Sadhana, please.
Sure. So that's all the components that kind of came together for implementing this. As we called out earlier, the whole demo, the deployment is on cloud. And so we are making use of, the cloud native stack to support the solution so that it can scale, meet the demand. You can, as I mentioned earlier, the central part of this architecture is the event stream. So that's going to be a backbone of this architecture, which is where we see Kafka coming into picture. So we have AMQ streams, which is basically our enterprise version of the Kafka offering that is basically deployed. In this case, I have a 3-node Kafka cluster that I've deployed. This is the central piece, and every other microservice, every other component is basically interacting with the stream. We have the integrations being deployed as Camel K integrations. So Camel K is again a recent addition to our integration stack. It provides for a very cloud native, lightweight approach to defining integrations. And you basically do that using simple kind of definitions. You provide a simple file definition, and that basically allows you to skip out a lot of the code that we write around the integration itself. So you just define the route, and everything around that is basically generated using code generation techniques, and it is deployed using the Quarkus runtime. So that basically kind of provides a very nice view there. We have the Elastic cluster, which is on the right, and that's basically what we're using for the reporting. If you remember, I mentioned, in my case, I'm actually pushing out all the metrics to to a Kafka topic, and we're using a simple service that will just read all of those messages and push it to the Kafka cluster. So that's how it ended up coming into the Kafka cluster. We have Cogito decisions. Again, I called out the significance of Cogito decisions in here. We are looking at minimum footprint, high throughput, faster decision making, and Cogito is essentially built for that. So we're basically making use of Cogito decisions there. Data grid, again, I mentioned about like providing faster lookup to data. And every data lookup is essentially sourced via the data cache using APIs. And again, the customer context microservice is reading the data from the data grid and combining that with the Open Data Hub, the APIs that are being exposed. So the model server APIs that are being exposed for that purpose, it's basically combining that, and it's providing the context for the evaluation. And then we have the business automation operator, which is where you have the regular key server, which is where I deployed my workflow. But in the future, that can be a Cogito process as well. And then we have the simple UI applications that provided the visual feel for us to kind of understand how all these pieces came together. And all of these pieces would essentially be in different namespaces in a real life scenario. I pull them into a single namespace just to show, the different pieces that are coming together to make that architecture possible. Yep. Karina, do we have any more questions here? That's
Yes, we
pretty
do.
much all that I had, actually.
Awesome, we do have. So how do you inject the history into the streams correlated to the customer? No, correlate to the customer and be sure that the history is complete.
So again, we're going back to this concept of creating the customer 360-degree views. And when you talk about data engineering or data services, it's a topic by itself. There are several ways you could do that. Event sourcing, as I mentioned, is a good way to kind of take data out of your legacy systems, databases, push that to a stream, and then have that, correlation being done based on that event data that is being received. The thing to kind of note here is I'm using Fuse, and again, Fuse is essentially built for that purpose, providing several different out-of-box components to connect with multiple external systems. So essentially, it can act as a way by which you can pull data from different sources. This can also be switched out to with other data services that you might have within your organization already that provides ETL type capability. You can combine that with Fuse and with the data caching that we spoke about and provide that holistic view. And when you say, how do I know if it's complete? That's a process, right? So when you actually deploy an architecture like this, the reporting and the analytical view is going to give you an understanding of how well your models are performing, or if there's any missing data that you will need to hydrate to make your models better in the future. So it's a iterative process, and it has a feedback loop that's tied into it. So I would say it's a continuous process. Nobody is going to get it right the first day. It's an evolution.
Yeah, and considering the flexibility that we might achieve here, have you considered using Debezium in this architecture?
Yeah,
I'm sure you just capture the events, push to
yeah.
Kafka, and handle accordingly.
Yeah, that's exactly the point. So when I spoke about even sourcing, Debezium is a natural choice for that because we can do that both for legacy applications without kind of hurting any of the original setup, keeping the legacy applications intact. We can basically perform a simple kind of outbox pattern to tap the data from the data that you are of interest from that data source, push it to a Kafka topic, and use for that even correlation.
Yeah, totally. So you showed a lot of different components, and there's a tricky question here because this is a solution built with
Mhm.
smaller pieces.
Yeah.
So is there an operator to deploy this easily?
Yeah, great question, and I think that's something that I definitely am considering doing. There has to be a way to kind of easily kind of deploy this. We can create a custom catalog item and push this as an operator, but then um, it's actually a difficult question in the sense that it's, do I just keep it as a solution? Is this going to be flexible enough so that people can plug and play, add what they need, make it easier that way, or do we just provide like a template to start with and people just expand on it? So that's something that I'm still debating on. But yeah, good call out, and I'm definitely considering doing something like that.
Yeah, especially because you created this as a demonstration of how you can build a solution to solve this problem. So creating an operator is a great effort, I think.
Yeah.
Good. So, but still, there are operators to help installing each of the pieces. So
Mhm.
at least that's some help. And about the GitLab or GitHub for this demo.
Yeah, so I'll follow up the video with, and I'll attach it to the comment section, the YouTube video, especially because I have to just clean up the repo with some of the tokens that I have in there, just to make sure I do my diligence before pushing it out. Yeah.
Perfect. So look, just look after in this video description. I will put the link to the GitHub and also to the presentation slide deck. So there is a question here that is really interesting, Sadhana. That is, why Cogito? What not? Why not rules for decisioning? So I would like to talk more about this. So basically, Cogito is an initiative that started in 2019, I think. And with it, we could, you can stay, Sadhana, if you want, okay? With it, we could actually bring our capabilities to the cloud. So when Sadhana mentions Cogito decisions, Cogito engine, all of that is actually Druze, but running in a cloud native mode. So that is why you are going to see in the key community more and more of Cogito, but that is still Druze, that is still Optoplanner, that is still JBPM, but with this new generation that we are bringing, these new capabilities, new way of deploying stuff with Quarkus, with native compilation. So it's you can expect new things, but with the all the good stuff that we used to have, right?
Yeah, and if I can just add on to that, Karina, it's totally possible to deploy the same, implementation using a Spring Boot microservice, evaluating decision in embedded mode to kind of get that throughput that we're talking about. But I think when we're talking about Cogito, we're talking about increased throughput, scalability, the ability to kind of deploy this easily, developer friendliness, and since it's built for scale, built for cloud native, built for event driven, naturally, because it has the hooks to kind of connect with a Kafka topic natively, it felt like a natural candidate in there. But it's completely possible to change this using a regular key server engine, and the end-to-end execution will look the exact same way. With Cogito, you get better performance, of course, but it's completely achievable, and the DMN models are not going to change either.
Exactly. So I think we even need a key live just about architecture. But all you can think of is like, are you deploying with the key server that we are used to deploying on EAP, on Spring Boot, or do you want to go with the new capabilities with Quarkus? So and also Spring Boot, but still, We should do one KIELive about that. I'll plan that. So great session, Sadhana. Let me see where this is so I can take this thing here. But great session. Everybody just loved the demo. I'll make sure to put the link here for them to reference later and see it and try it for themselves. So thank you for joining us today, and I hope I can see you more with all other, because I know you have other nice demos. So if you invited, you are now invited to show up more and whenever you want. Okay.
Sure. All right. Thanks, Karina. It's great
Perfect.
being
Thank you,
here. Thank
Sadhana.
you.
Hey, see you on the next KIELive, where we are going to talk about how you can optimize the way you plan the tasks in your processes for Cogito with OptoPlanner. So see you in 2 weeks, and thank you for joining us today. Bye bye.